In the previous lecture, we talked about the concept of mesh analysis, but we only looked at mesh analysis when there were no current sources. So in this lecture, we're going to actually look at what happens if there are current sources in my circuit. And so the best way to look at this is by going through examples. So consider the following example here, and I have one current source, IS1. And so I have defined, as before, my three meshes. So meshes, again, remember, were basically loops in my circuit that did not contain any other loops within it. So I have three meshes, A, B, and C. And for mesh B and C, I can write a KVL equation, and I can do it directly by inspection. I can go around the mesh and basically write down the sum of all the voltage drops and voltage gains, and write it as function of the voltage sources and the mesh currents through the resistors. And that's what I have done here. So I have these expressions for mesh B and mesh C. However, I cannot do KVL on mesh A, because I do not know what the voltage is across this current source. Remember, a current source specifies a fixed current that flows through that branch, but the voltage across the current source can be anything. It's dependent on the rest of the circuit. So we don't know the voltage across this current source, and so we can't apply KVL in mesh A. However, the current source is only in one branch, so I can just see that IA is equal to IS, and that's actually my missing equation that I can use. So it is easy when the current source only appears in one of the meshes. Like in this case, I can just directly write an equation like I've shown here. Now, consider an alternate scenario where there is a current source, again IS1, but it's now in two of the meshes. It's both in IA and IB. So what can I do now? Well, as before, I can still look at the meshes where I can apply KVL. So for example, in mesh C, I can apply KVL as before. So this is just KVL in mesh C. And I also have, as before, the relationship between voltage and current for the different circuit elements. Now I'm wondering, well, I can't write KVL anymore for mesh A and B because I have that problem with that current source, where the current source, again, I don't know what the voltage is over that current source. But I can define what's called a super mesh. So consider the circuit, I can define a super mesh, which basically combines the two problematic meshes A and B and avoids the current source. So it's the mesh that I get when I combine mesh A and B, but I avoid the current source. It's also marked here with this faded yellow line. And I can actually do KVL over the super mesh. So I can do a KVL around here. So by avoiding that current source. So I can write the new KVL equation. So this is a KVL around the super mesh. So now I have two equations. I need a third one. And again, I can find the third one by looking at and using this current source. So now look at the current source. I see that the current source actually finds a relationship between those two mesh currents, IA and IB. So when I look at the whole system of equations now, I have three equations and I have three unknowns, IA, IB, and IC. So again, three linear equations, three unknowns, and the system is solvable. So this is the procedure that you follow when you have when you want to do mesh analysis, but there are current sources in your circuit. It depends whether the current source is only in one of the meshes, then it's very easy, or when it's in more than one of the meshes. And in that case, you need to create a super mesh. So now we know also how to do mesh analysis in general situations.